Hey, what's up, folks? Welcome back to another 3D Hangouts. I'm Noé Ruiz, designer here at Adafruit. Joining me every week is my brother Pedro.
Good morning, Rod. I'm Pedro Drives, creative tech here at Adafruit, and every week we're here to share 3D printed projects featuring electronics from Adafruit.
That's right. This is a show we combine 3D printing, DIY electronics, smash them together to make inspirational projects. Hello, everybody. We are live. This is episode 482. It is May 14th, 2025. We're hanging out in the Adafruit Discord server, so if you'd like to join us, go to the Discord. The URL for that is, let's bring it up here, our little social media banner, discord.gg/Adafruit. And we'll take a couple minutes to let folks say hello so we can shout them out. We're streaming on Facebook, LinkedIn, YouTube, Twitch, X, and that's it. So if you are over there on those other social channels, we can bring in comments, questions, GIFs, GIFs, memes, all of those and more. We got a big show for you folks today. Hopefully we can get everything in. We got a new project. We have a really fun shop talk with kids, Pedro's kids, my nephews. We have a new rapid render segment as well. And a Timelapse Tuesday and a couple of community makes. Hopefully we can fit everything into our hour slot. So let's go ahead and go to adafruit.com/free and find out what are the freebie deals this week. They're pretty much the same as last week, but let's go through them as we tend to do in the beginning of the show. For orders of $99 or more, folks are going to get a free PCB coaster with a golden Adafruit logo. Or you can use it as a frisbee or something else. If your order is $149 or more, you can get the freebie PCB coaster and a free KB2040 microcontroller. That's actually the main brains of our camera slider project this week. And if your order is $199 or more, you'll get the KB2040, the PCB coaster, and free UPS ground shipping for continental US only. Adafruit.com/free for all the details. And these get automatically added to your cart. And if you are at your checkout, why don't you use our coupon code SLIDER to get 10% off your order. It's good for the next 24 hours. Expires midnight tonight. SLIDER. That's the coupon code. And we appreciate everybody putting in their orders for all of their parts. Okay. Back over on Discord, I see we have Duester. Good morning. Squid.jpg. How you doing? And on everywhere else, nobody's saying anything else, but hey, we're listening. So
Looks like there might be some issues sending all the stuff in. It's like,
what do you mean?
Some of the destinations cannot post comments.
Really? Oh, interesting.
You know how it is.
Yeah. Sometimes, normally Facebook is the one that has like an issue. And LinkedIn, sometimes when you have too many links, it's like, I can't do that. Anyway, let's see. Let's go back to our things. Yeah, so this week's project has been in the works for 3 years, maybe more. The motorized camera slider is a thing we've been doing for a decade now. And every year we kind of make a new version, maybe every 2 years, something like that. We make a new version. The first one was no electronics, just like a slider thing. The second one was like, I think we added Bluetooth with a Bluetooth shield for an Arduino. And then we did another version where we just updated the mechanics. And then another version where we did the CircuitPython slider. It was our first collab with Liz Clark. Shout out to Liz Clark. And then finally, we did a 2-motor version using the lovely silent, smooth and silent stepper motor drivers from Trinamic, particularly the TMC2209. So after lots of work and documenting, finally published this Learn Guide. It's a big one. It's meant for advanced makers because there's just a lot going on here. There's a custom PCB that we designed to reduce some of the wiring. It's a lot. So we kind of looked at it a little bit last week, but this week we'll kind of go through it, and I have a little video prepared of me and Liz using it outside at our local park, and we're just going to talk about what it's like using it, how you want to use it, what shots look good, what shots might not look so good, some of the features and stuff like that, how to mount it on C-stands and things like that as well. So the overview page just talks about it. I think it was really cool that Liz came up with a way to pose the start and ending positions of the panning. That was like kind of the hardest thing to figure out with this project. Like, of course, you can easily do a pan from left or a slide from left to right, but how do you make it so that you can set a beginning position or pose and pose? So Liz came up with this idea that you could use the rotary encoder to set those positions for the second motor there. Most of the parts are in stock. It looks like we have the KB2040, the buck converter to take that 12 volts and power it to give it 5 volts that the KB2040 needs. We got a little display. It's a 1.3 inch display. It is a color display, and it's connected through SPI, which is a lot of wires, and that's why we made a custom PCB, which we'll talk about. The rotary encoder is out of stock, but maybe have one on hand, or you can find one from Amazon or any other electronics places. They have rotary encoders. It is the one that has the click, so you can click to select stuff. We have an 8X battery holder, which is actually, that's what gives us the 12 volts and makes this whole project portable, which is nice. You don't have to plug it into the wall. And then what we tend to do here is after 5 of these hero featured products, we break them out into this list form. And there is a lot of them. A lot of the things are, JST connectors for the end stop switches, quick connects for the end stop switches, a micro switch, the slotted aluminum, DC barrel jacks, terminal blocks, so on and so forth. Resistors, because we need those resistors for the UART. Again, there's a lot of parts. That's why we're advertising as an advanced maker project. And then parts from Amazon. We just don't stock a lot of the things we used to stock, like the timing belt, the timing pulley, tripod screws. We still stock them, but I'm using a different one with a different length and all that. Batteries, rubber washers, rubber feet, bearings. Like this is a big bearing. And then the stepper motors. We do carry stepper motors, but I found a short body stepper motor works really well here because they can get pretty long in the tooth, or long. So a short body stepper motor is really nice. So those are just about all the parts. Hopefully I've added everything. And then onto the circuit diagram. So again, we were saying we needed a custom PCB to make this work, because if you scroll down here, you can see just how many wire connections are needed. There's 8 or 10 wires just alone for the display, because we're doing iSpy, which is the fastest way to kind of connect to display stuff quickly on the display. You got so many connections for the rotary encoders, the end stop switches, the buck converter. There's a lot of stuff going on, and so that's why Liz decided that she's going to do the PCB. So here's the PCB. We do have it in Eagle format, in Gerber files. So folks can download this from GitHub if they want to make changes. They can bring that into KiCad, and make all sorts of edits and changes if they want. It's all routed and ready to go. And then we also have a dedicated page on ordering it. Shout out to, I think it was John Park, who suggested, why don't we have a dedicated spot for how to order the PCB. So if folks haven't ordered a PCB before, there's many places to get your PCBs from. So we have some of the 3 top ones that we like personally. Of course, Osh Park here in the States, you can support a USA manufacturing. They actually do manufacture PCBs in-house, which is amazing. It says $54.35, not including shipping, which is a little on the pricey end, but that's what you got to pay if you want stuff made in the US. And then other places like JLC PCB, with the tariffs and stuff, I can't really calculate what the price is going to be. So that's why I don't have it listed, but you can upload it, and you can get it in about 1 to 2 days. They'll make it, and then they'll ship it DHL or UPS. I'd recommend DHL because that's what we did. And things are changing. We try to order. I got a story here. We tried to order it from JLC PCB about 2 weeks ago, and they wanted our social security number.
What?
And we're like, why can't we opt out of that? And we couldn't figure out why. And it's just like a security tariff, new rule regulation. We don't know why. You could search it up, but they wanted our social security number. We're like, let's go to PCB Way, and it's optional from PCB Way, so you don't have to put your social security number. So we felt safer ordering it from PCB Way, but they kind of seem to be like the same. They have the same kind of, you know, ordering setup. So you might as well pick what you want. Like, yeah. And this is a new note here that I actually didn't know about. That just talks a little bit about the tariff situation. So it's always changing. So I don't know.
Hopefully this gets outdated soon and we get to remove it.
Yeah, right. We should just
supposedly now it's like paused for 90 days, which, you know, doesn't include the, I saw it in the chat. What was it? Doesn't include the 30% that was already on there. So it's like, who knows what the heck it is.
Right.
Hold on, checking in the tariff talk Slack chat.
Yeah, so things are always changing, but the bottom line is
it's 25 plus 30%, so it's really 175%.
Yeah.
Yeah. So.
Oh,
good. You'll get the bill in the mail.
Right.
You expect it, and you'll be like, "What the heck is this?"
Right. So, yeah, custom PCB. We haven't really decided whether or not we want to start stocking this thing, because it's a very custom PCB for a one-off project.
Yeah.
Maybe it could work for other projects. We just haven't really talked about it. We're very busy on other things. But this was the best way for this project to be possible. It really helped to have a custom PCB made. Yeah. So that's the ordering PCB page. End of rant or story. Onto the CAD files. The CAD files are all open source. We have a step file for folks that they can open the original, you know, modifiable parts. We have 3MFs. We're kind of moving away from STL because 3MF provides a lot more metadata, and they're just a little bit better supported, I guess, in slicers these days. So I have all the parts arranged in different plates for the Bamboo Studio app. Maybe it works with others. I haven't checked, but we're like fully on board with the Bamboo style printers. So that's why we're like 3MF, you know, here you go. There is a little bit of support material required for the end caps because they are a print in place thing. And just to kind of make it simpler, support materials are really good these days. Just one setting, I think there's like one checkbox that says support critical regions only. And I love that they have this setting now, because before you'd have to painstakingly add support blockers to specific areas of the part. Don't need to do that anymore. You just click on one button that says support critical regions only, and it only adds support where it needs to, which is nice, because if you don't have that checkbox on, it just adds supports everywhere and they're not needed there. But those are the only two parts. This part here, I'm calling it the lever cap. It's the thing that bites onto the timing belt, and it has a built-in lever and hinge that allows you to keep tension and keep biting onto the timing belt, which is pretty cool, pretty clever. The biggest part here is listed, so if you have a smaller printer, maybe it won't fit, but this is kind of the biggest part in the whole build. It's this the bottom carriage part, which is the dimensions are laid out there.
I don't know any other printer that is smaller than 140.
It's a 170 on the Y. So yeah, I'm not sure what the bed size is on, like, let's say the A1 Bamboo.
I think it's the same. Correct me in the comments.
Is it
not the
254? Is the Bamboo
tools
X1
to split apart parts is really good.
Yeah,
it's like a puzzle piece, or it has like you can add where you want the little dowels to go and different shapes for it, custom placements.
Yeah,
not even a problem anymore.
That's good. All right. Well, just as a FYI for folks. So, yep, we have the CAD. We also have the Fusion 360 file, which has the original components. It has the PCB. It has all the gears, the aluminum extrusion and everything, and stop switches. Just about all the electronics, which is nice. Yeah, but I like the 3MF all parts file has all the plates and all the parts oriented for you. So you can pick and choose what colors you want, or, you know, I think I distributed them pretty nice on plates, which is cool. Yeah, those are the CAD files. Next up is the installation for CircuitPython on the KB2040. So this is just a boilerplate mirrored page from the KB2040's main product guide. Just walks you through installing CircuitPython. It's a lot easier than what I'm seeing, but it's just very thorough, because you got to be thorough. Big shout out to Liz Clark, of course, for coming up with the code. It's all broken out here. Things are changeable here if you want to change a couple things, like the time lapse mode has like different options for different timings, so you can change those if you want a longer time lapse. Let's say you want a 1 hour time lapse, you would change the 30-minute to 60-minute, and it's just like all in text here. If you had a different display or something, I guess you could change that up. If you want different fonts, you can change that up, which is really nice. If you want to have like a super cool custom interface, you can do all that here. Right. But Liz breaks it down. There's a lot of code because there's a lot of functions and features in it. But yeah, we have the stepper driver, the UART device library, the icons, and the bitmap all accessible to download. And then she breaks down how all the code works, how we're initializing the keypad, the TFT, the encoder, the graphics, the UART mode for the stepper motor, the menu system, moving the motors, and the loop, and the keypad events. So it's all there for folks to take a look at. It'd be a really good jump off point if you want to do something similar, but your own build. And then onto the assembly. This is a dedicated page on setting up the PCB, populating it with socket headers, because we like to keep it modular in case something burns out, which would be hard to do. But yeah, you have all the socket drivers, and then things that make it easy, like a DC barrel jack for the battery connector. You got some screw block terminals here for the powering the stepper drivers, the rotary encoder, of course, some JST connectors. Make it easy to use the quick connects, because they use the JST connectors. You just plug those in, and there's no soldering required for the switches, because they're quick connects. They just kind of bite into the terminals, which is nice. We got those resistors. They're 2.2K resistors that are required for running UART mode, which is a little weird, but that's how it is. And then we're just soldering up all the things. You do want to have some extra wires for connecting the PCB to the stepper drivers. There's no broken out power pins on the stepper motor other than the screw block terminals. So that's why we have this weird kind of like screw block terminal to other screw block terminals. And it would have been a lot of, we did consider, like, why don't we just make a custom PCB with all of the components? And that would just be a nightmare, because it's just like another month of development for, you know, getting the RP2040, and instead of, you know what I mean? Like it was a lot easier to make a carrier board than like a dev board. And that would require a lot of development. But anyway, the last component here was we're putting on the display, which just plugs into the sockets there. We talked about this last week, setting up the panning motor with the ball bearing and the stepper motor and the tripod screw stuff and the 3D printed gear for the stepper motor. So that's all broken out there. After that, we were working on the carriage assembly, starting off with the end stop switches, the battery holder for the bottom of the carriage, setting up your stepper motor with the 36 tooth timing pulley, some M3 screws, just installing that all in the right order, getting the battery installed. This is kind of optional. If I imagine folks would want it to be portable, so that's why we got the battery pack clip holder thing designed to go on the bottom of the carriage. And then we're installing the gear for the stepper motor to go on top of that. We got timing pulleys or pulley wheels with some M5 screws, and then installing the quick connects to the end stop switches. you kind of create the sandwich with the top and the bottom carriage plates. And in between those two are the timing or are the pulley wheels. And then we're using these big M5 screws to kind of secure those two pieces together. We got some hex nuts that we use to secure those pieces together, and some hexagonal like captions that capture the hex nut, which is nice. And then the battery's installed. I have dedicated PCB plate for the PCB, so that gets installed after the carriage is kind of assembled. And it's really easy to press fit the panning motor assembly to the carriage because of the ball bearing. So that's how. And then we're just threading those cables for the stepper motor through the center. It's got a nice big inner diameter. The rail assembly. This is where we're installing the two aluminum extrusions to the feet, and then we're just sliding the carriage onto those two extrusions, and then just tightening everything with those M4 screws. The timing belts, you'll want to cut it to length, so just measure it out, the length of the extrusion. And then we're installing the end caps and then installing the belts. So the belt goes over the timing belt like this, like right through the timing pulley that's on the stepper motor. And it looks like we now can, we had a bug and I think we're fixed now. Let's try it out. So if I click on this image, yeah, look at that. So now you can see the full image here. If you want to click on that and the side to element here, you can roll over to view the image, and now you can click it to enlarge the image, and you have a couple different image sizes here. That was a bug that recently got fixed in the Learn system. So shout out to Justin for fixing that. Yep. And then here's how you lock and tension the belts. You just thread it through and under the lever, and then you just kind of, you can see the bottom here, how it's working. It's just like this print in place thing that, and you can see that there's a little teeth here, and then you can tuck the excess behind this little flap here. So I can zoom in on it and show you kind of how it works here. So as you pivot it, it bites into the timing belt, and that's pretty clever. Cool. And after that, we're going to connect everything. So connect up the plug in the JST connectors from the end stop switches. We got a nice breakdown of the the colored wires from the stepper motor into the proper pins on those two stepper drivers. We have some hardware, to attach the PCB to the PCB plate, plug it in. And then we got this, of course, the rotary crank, which is one of my favorite things. It works out really well here in this project. It's a printed place crank with 2 hinges, and it's designed to fit over the shaft of the rotary encoder. And that's a little GIF of the slider in action, panning and sliding at the same time. Usage page walks you through how to set up a shot. So whether you want to start it on the left or the right, you'll push the carriage until it actuates the end stop switch. And depending on which side you actuate, it knows to go one direction or the other direction. After that, it wants you to set up the start position. So this is where you can use the rotary encoder to position the panning motor. So you can line up your subject, and then you can, once you click to set that position, the screen will tell you, okay, set the end position for the panning motor, and then you use the crank again to change the direction or the position of the motor. And then once you lock that in using the select button on the rotary encoder, you're setting up modes. So what are the difference between a time-lapse mode and a one-shot mode? Well, the only difference is that the time-lapse mode have longer durations. So if you want to set up a time lapse, you have the option to do a 1 minute, 5 minute, 10, 15, and 30, all changeable in the code. If you want to do a longer time lapse, change that 30 to a 60, and there you go. You have an hour. So that means it'll take 30 minutes for the carriage to go from one side to the other side. And then the one-shot mode is just for shorter video clips. It's designed for clips that are 20 seconds, 15 seconds, or 10 seconds. So that's slow, medium, and fast. I tend to use all of them, really. It really depends on how quick do you want to do it. I tend to do the fast because like 10 minutes to capture a subject is 10 seconds rather, is pretty much kind of fine, really. Like you don't really need a shot that's any longer than that.
Yeah, you end up trimming off the ends anyway.
Anyway, yeah. So, and then once you select your mode and you set your option for the mode, it wants you to click go, which is a nice interstitial because it allows you to kind of record or focus your subject on your camera. And what kind of camera? That's up to you. DSLR camera fits. The biggest camera I've tried on this is the Blackmagic Pocket Cinema, I think 4K camera. That's what it's called. That's a pretty decent sized thing. That's like maybe a pound or two. I haven't tried my 5D because it doesn't do 4K video. But I've really been using my iPhone a lot because it has 3 lenses and it's got built-in image stabilization, which you kind of don't need because the stepper driver is so smooth and the rails are really smooth. It's kind of nice. It's very silent because they're, the other ones were very loud. But yeah, that's the Learn guide. I think it's pretty thorough. If anyone builds one, I'd love to see their build or make some modifications. Hit me up on any of the socials or Discord, anywhere. It'd be really cool to see folks build one if they do have a need for one. And with that, I think I'm going to talk about how we use this in real world outdoors scenarios. So on Friday, it was the only day that wasn't raining. So we thought, let's go to our local park and film some stuff. So let me walk you through, folks, on how I set up a shot and how I'm using this feature. So here we go. So for starters, we have 2 C-stands. I'd recommend 2 tripods because that'll give you some really good stability. But the mounting feet do have dedicated 1/4-20 tripod screw holes, so you can mount it to a tripod or a C-stand. And here I'm setting up a shot where the first thing I want to do is slide it to whether I want it on the left or the right to set up the trigger the end stop switch. And then it wants me to do the starting and ending position. So here I am, I'm actuating the end stop switch, and then I set my beginning position. Then I'll slide it to the other end so that I can use the rotary kink to see what the ending position is like. I'll lock that in, and then I can slide it back to the beginning to kind of preview. And this case, it's the iPhone. And then I get it ready. I start recording and I hit go. And this is, I think, a fast one shot because it's about 10 seconds of motion here. And here's what the end result looks like. Nice. Pretty smooth, pretty cinematic. That's what it's meant to do. This is just a vintage water fountain at our park. We also have this statue of a unicorn, which is pretty cool. And I had these set up, on C-stands. This is using the 2X lens built into the iPhone, which gets a little bit tighter shot, and it looks really nice.
Beautiful.
Yeah. Also, we have this this looking out point, which is like looking out kind of like as a cliff. So I try to do a little time lapse here. It did move a bit because there wasn't on C-stands; it was on an unlevel bench. So just keep in mind, like sometimes time lapses don't come out well if you don't have like a nice level surface. So you can kind of see a little bit of a jitter there.
Oh, you said the rubber feet and
I didn't get my rubber feet yet. Yeah, so there are some additional holes on the feet mounts that have M4 size screws for adding rubber feet. So you can do that, or you can do one of those things where you have like a lung bolt and then you use hex nuts so that you can kind of leveling legs. So you can get those too. You can add those to the print, to the part. let's see, continuing on. It is pretty low profile, so putting it on like a rugged terrain like rocks is, you know, it can be hit or miss. Like there were some parts where like bugs, spiders were like getting on on it. So you know, keep aware of your surroundings. And some shots don't work that great, especially when you're trying to slide and you have this big subject like this giant rock. You can't really quite tell that you're sliding. You need things in the foreground to know that you're sliding. You only have about 17 inches of travel. So it works better when you have a smaller subject. So here we have a flower bed. We got a couple statues, a couple of flowers, which work really well. So smaller subjects, a close up probably work better than farther away subjects. And here's that flower bed in front of the park. Yeah, it was a really nice day. And that's kind of a quick look at using the slider in real world outdoors. I was able to find a C-stand bag that's the right length and stuff. I'm not going to link that because it's, you know, you can find your own bag kind of thing. But if you do want to use it outdoors, it makes sense to have a some sort of carrying case. Yeah, I'm trying to think what else, other things. I had some thoughts about like maybe design a handle at the bottom carriage, but it's just, at that point it's just like I'm feature creeping here.
Yeah,
you know, I need to document this thing. Yeah, it's a good jumping off point. So if folks want to add that handle or different ways to mount the feet or a different feet thing altogether, by all means, you know, change it up. I've also thought about changing the way the camera plate is. Like I feel like it's too tall. Like I feel like you could reduce the height of it. But that's all stuff that that folks can change if they want. You know, all the Fusion 360 files all parametric, so folks can change that if they need to, or use the step file if you want to change, you know, the camera plate or something. Maybe add a quick release plate to it would be really cool. Obviously, you can make an enclosure for the PCB because I didn't get a chance to really nail down an enclosure because it's kind of thick because of the headers. You do have the option to use short headers. You can do that if you'd like to reduce some of the thing, or use no header, use no socket headers at all, and just solder directly to it. That would make it really thin. So all sorts of options. We got a comment here from Night Cree Paul on YouTube. I would imagine outdoors would give the best effect with longer depth of field. Yeah. Closed in areas might need longer rails to get a decent effect. Yep, that's a good point. Yep. Yeah, it's all about just like try it out and see what it is. But the ideal shot is like you have a subject in the center of the frame, and then your end and out are like keeping that in the center of the frame. I think that makes like the best kind of shot. And then this kind of shows that you don't need to necessarily have a start and stop for the panning. You could just do like a straight slide in or slide out shot, which we tend to do a lot in our product videos. So, yeah, all cool methods of using the slider. I'm sure there's plenty of YouTube videos on like how to set up a shot for a slider. But the main thing was like, it's kind of hard to get a slider shot where you're panning and sliding in like the same, in a nice consistent motion. Like it's really hard to do. So that was kind of why I wanted to make this. And commercial ones still are pretty expensive. 500 to 1,000 plus minimum. Some of the better ones. Yeah. I'm sure you can find some of the cheaper ones too on Amazon, but
no, I've tried. They are not worth the no.
Yeah.
Loud and then
yeah. Yeah. I haven't calculated the price because it's a lot of bips and bobs and like I'm assuming some people have tripod screws, maybe you have AA battery. Like I don't want to calculate everything, but I'm guessing it's under $200 maybe.
Hmm.
I'm thinking with the PCB though, maybe that's another extra $50. So I don't know. It depends. Depends on what folks want to do with it. But
Super
it
cool.
was mainly for our use, and this is the thing that I've been wanting to make for three years now. Finally here, finally got it. Yay. Woo. So that's just this week's project. It's a long one. Excuse me. I got like burps. Excuse me. Oh, live stream. So if folks want to build something like that, you can use your 10% off coupon code SLIDER. Get 10% off your microcontrollers, motors, batteries, all sorts of stuff.
Yes, I believe the batteries are still in stock, or at least the battery case for it.
Yes. Yeah, I like that battery case. All right. That's the learning guide. It's published. CAD files are all up there. Oh, what's this? Regret Amazon purchases to use more and more now these days. Even small parts and components have been dismal.
Yep.
Huh.
Yeah, I had to return one of the little panning tripods because it was super loud. It was super jittery.
Really?
Oh yeah.
Yeah.
It's like giant too.
Yeah. Some of the white label stuff.
Yeah, good point from Amari saying that if you make the PCB yourself, that should bring the cost down a bit. Yes.
Yeah, for sure. Yeah.
Definitely.
Yeah, there's two methods. You can either CNC one, I guess, or you can do like the chemical etching. I haven't done the chemical etching.
Oh, yeah.
The PCB one is definitely a thing. We have a tutorial on how to apply solder mask and stuff like that. Yeah, that's definitely a good option. It is a two-sided board. There's no vias, so that's good. That's really hard to do with CNC, is to do vias, especially with the FR1 material. Double-sided FR1 is a thing. I've done it. Alignment is a little tricky, but definitely doable. Yeah, that's a good idea.
Oh, there's a couple comments here.
Yep.
The Mari saying you can use the M12 batteries to get 12-volt power. Milwaukee ones.
That's cool. Yeah. Yeah. So the battery holder on the bottom of the carriage is completely independent. You don't need it. You can create your own one. So if you want to make an adapter or just zip tie it or something, you can do that. But yeah, I like the idea of using like a power tool battery. That's a good idea. I like this one because it's nice and flat, so it keeps it low profile.
Relatively thin,
yeah.
Let's see. Okay. Yes, most of the PCBs are in-house, but again, this is so niche that we're not making stencils for this.
Yeah. Nope. It is so niche. Yeah, I'm not sure who we use to manufacture PCBs, like like let's say the KB2040. Lamar has that all covered. I think we still use JLC PCB for our prototypes though, which is a great option. But yeah, things change. Sometimes we'll use PCB way, I think. Cool. Good stuff. Good questions. And if I end up making like some modifications or add-ons, I'll share it for a Shop Talk, future Shop Talk segment, and see like, oh, I found out that it's actually better to do this way or something. So maybe I'll revisit it and stuff because I will be using it, for projects. Cool. All right, folks. Feel free to drop anything else as we continue on through the show. We're a little over. We'd like to keep the Learn Guides 30 minutes. So let's go ahead. What's next?
All right, let's go ahead and jump into this week's rapid render. Should be a quick one.
All right. Are you doing it?
Yes. I was waiting for you to put the banner up.
Oh, okay, I'll put the banner up. Ready and banner. Rapid render. Here we are.
This week's rapid render is a really cool one by Zoo. It's a desktop app, and the main draw to this is being able to see the code that is generated with your 3D model. So we jump into the guide here. You can see the website for this, just a little breakdown of everything. Like like they're showing here, all of the actions that's going on is coincided with code, so you can quickly edit things like the diameter, the fillet, by quickly jumping into the code and seeing how that generates. They do have an AI function to sort of tell it to shell out an object or how big you want the diameter to be. So that is pretty cool. I do try it out in the video I'll show, but it looks like it was maybe shoehorned in because a lot of the features are still being worked on. A lot of the errors and pop-ups for things that are features, which is selecting a face or an edge after a instruction has been applied to it. So let's go ahead and jump through that. Go ahead and bring up the video for it. So here's what your project workspace looks like. So when you create a new one, I have to like scrub through this video. So you're set up with your origins, your little sketch tool to draw out your items. So one of the things I'm trying to do here is like just snap to the grid, and I couldn't find any way to do that. So I'm just like drawing to sort of familiarize myself with navigating inside of the sketch plane. So what I wanted to do was just create, see what their pen tools are like, how their Bezier curves act, basically just see how the code is generated. So as I'm navigating around here, you can see on the left hand there how the programming for this, how the like the radius is update, how like the extrusions update. And here in the top corner, it's so tiny, it's like a little sparkle icon where you can input your prompt for AI. So the prompt that I'm using is simple things like, extrude 5mm width with like a 1mm shell, just to see what it would do. And here's a result. It gives me a square, which, okay, that's, I was hoping that it would know context based on what is selected. Like, I had the circle selected. You should have extruded that with the shell. So here you can kind of see like the errors, clicking on just the face and the edge, and it's giving me an error that, it's not able to actually continue to do any more operations on top of that. So drawing more stuff on top of it to try to loft between different objects, and I had trouble doing that. Yeah, so a little bit of bug that they have to take a look at. I did like that it was a drag and drop application, but it looks like it's using web hooks to actually sort of do the operations, sort of like Fusion is, where it's off-site on a server doing the actual calculations for whatever, like a Vernoy or something like that. So here I'm just trying to translate this like on the z-axis, and I could not find a way to do that. So no way to like offset a plane or move things around where it's just a sketch. So I'm trying to, in the prompt, trying to tell it to move things around, and it's not really working. So definitely still as sort of an app to explore, not to really, for us anyway, that want to do projects for it. And I'm just scrubbing here. I think the video might have frozen on it. I'm trying to show what of some of the other AI prompts that I'm using that it just did its own thing.
Yeah.
Is it? Yeah, the video is not quite. Let me see if I can close this out.
Well, you troubleshoot, I could talk about my experience with it. So before we did rapid render, this was the first AI CAD application I tried using. Yeah, I found it a little weird too, but I don't know, maybe it's getting updates. I think I tried doing a prompt that I saw on their homepage. Like I wanted to create a gear with 32 teeth that are,
Oh yeah, I remember that.
And I basically did verbatim, and it didn't generate the model that it showed generated on their homepage, which I found very sus. Not to ding them or throw shade. I think the idea is great to have a programmatic It's almost like an open SCAD kind of idea where you're creating an object through code, and then you have values that you can update quickly on the fly. So it's completely parametric.
And that's exactly what I'm showing off here, where I'm just going into the code itself and updating, you know, the shell thickness. So that's pretty cool, where the actual structure of your sketch and layout, and your shapes and your solids are quickly, you're able to go into the code and update a value without having to go through any of the tools or figure out the navigation for that.
Yeah.
So I'll give it that, but that's pretty cool.
Yep.
To be able to jump into there.
Yeah. A bit of a learning curve, I think, to understand how it works. Especially trying to use the idea of like using their sketch tools and then their text to prompt. I don't think they're tightly integrated yet. It's either you use one or the other, because if you try to do a prompt on an existing model, it doesn't seem to apply it.
I think that's what's going on.
It just kind of starts a new thing. And there's the notion of a feature tree, which is kind of like a parametric timeline. So you can see, you know, layered features that you're like putting on top in this tree format, which is interesting. It's pretty cool. It's pretty neat. I've been wanting to make a simple holder for my coffee filters, so I might use it. I've been wanting to use this to create a simple box that you have here, like, but it's shelled, and then you can say how thick you want it, what the width is, and what the height is. So that's still something I need to do, is make this box for my filters. But for someone who's just starting out, this could be a good tool to check out.
So I'm doing here again, like what you're saying, this would be super handy as a, like what Thingiverse uses for their customizer tool. We're able to go in there and adjust the values and parameters to have it fit whatever object you want to. And here's where I stop it because it just failed. Communication error.
Yeah, right.
But this will definitely be helpful for that sort of application. The customizer, where we can have our projects be embedded inside of the Learn guide, and you can quickly go in there, update your values, and then export a whatever format, STL or M3F.
Yeah,
maybe with colors attached or something. That would be super helpful for some of these projects where the customizability would be the main hook for the project.
Yep. One thing I did try when I was first playing with it weeks ago now, probably a month ago now, I made a spatula, and then I was able to export a step file from there. So it was completely generated with the text to prompt. I said, make me a spatula. I exported out the step file, and then I imported that into Fusion so that I can see how it is. And it was individual, primitives, and then I had to merge them, and it was watertight, but I had to combine them. And, I exported it out, and it's like kind of just picked whatever size it was. So that was kind of neat.
I don't know why I closed out the video I was sharing, but yeah, super cool. Check it out. Again, they do have the download for a variety of different OSs, even like Apple Silicon and Intel. So
yeah, I actually have the native app downloaded. Yeah,
super easy. It's just a drag and drop on the Mac side. And I didn't even check out the diff viewer. Oh, of course, it's all on GitHub, so you can even check out some of the other things that might have contributors to it.
Cool.
So, super cool.
All right.
I'm happy that it's not behind a paid wall or anything. You can just immediately download it.
Yeah, right. Yeah, love the idea. All right, that's this week's Rapid Render.
Check it out.
Zoo. All right, that is our Rapid Render segment.
This is exactly what's happening.
Is saying I'm testing it right now, kind of loose with its design. Tried making a PCB box with a lid.
Yeah,
I see it kind of ends your prompt when it's done and no option to modify it. Yeah,
I think that's what's happening. So just some connection type things that need to be worked on, but looks like they are working on it.
Yep. Cool.
All right. let's go ahead and jump into this week's community make for Timelapse Tuesday. I actually posted it about these a couple weeks ago. It was these box crafting or cardboard crafting tools. And there is a company that we used to have these on the shop called Make Do, where it has these like screws and cutting pieces for cardboard, so you can create crafting projects with them. And it looks like they're still selling them, but these are just 3D printable versions of them. I remember when we were testing these out, Gavin had a lot of fun making like little houses and things. So this is super cool that he's teaching his younger brother to do some cardboard crafting projects. So it includes the little screws, the blade, little perforation tool, the little poker, and then of course the hex little screw to attach the little card box screw. Go ahead and jump over to my desktop camera and show what some of those look like. So here's what the screw looks like. It comes with several different ones, a longer one and a shorter one, and then the hex screw to have that go in, as well as a handle. They use I think it's M2.5 and M3 screws with hex nuts to hold on the little perforation tool. And then the blade, definitely want to use the perforation tool before you use the blade. Here's what the blade teeth will look like. You don't. Really? So I tried PLA, and this is PET G, and it melted it.
It's like, still melted.
Yeah, the teeth are gone.
Wild.
I know.
Gotta use ABS, I guess, huh? Or
I don't have any ABS.
Yeah, I don't either.
I definitely don't want to use it because we're using this in the kids' printers in their little school room, so I don't want to fill that up with toxic styrofoam or whatever the styrene, whatever the toxic fume is.
Mm-hmm.
So yeah, definitely use the perforation tool. Oh, I have cardboard here. You can kind of see how that works. You just press down on it. And I don't remember the Make Do's having a perforation tool. So
they do. Their newer kits do. I'm on their website. I'm looking at their tool sets.
Yeah, so you can perforate that, and then this pops out, so you can add the little screw tool for that after you punch your hole in, of course. So the kids have been having fun with that. And one thing I thought was super creative was this print in place little hinge that allows you to have like a little holder for the screw. So this would go in like that, and the screw goes over it.
Mm-hmm.
And you can add like attach, I don't know, stuff to that. And
yeah, like a string for a sign or something,
exactly,
or clothes hanger kind of thing. It's cool.
This little guy here for like holding on to rubber bands, so that this will go over that side there, and then you can join two different pieces of cardboard with these guys here. And then the way that the perforation tool is working is it's like 3 pieces, this little center like nut that it goes over. Cool.
Yeah.
So yeah, apart from having to do your perforation first.
yeah. So that makes sense. Or I have a little note here. These are really cool. I love the addition of like creating your own tools. Here I have a really good tool. You have it right there. So this, the canary knife is a really good tool.
This is what kids had to resort to.
Yeah, I love this tool. We do sell it. Here it is on
I forgot we did.
$10. It's still in stock. Like
it is.
It's like cutting like butter. Like it's really nice.
Yeah.
It's Japanese made tool. It's engineered for cutting cardboard. Love this thing. I actually want to pick one up.
Oh man, I had to get like 3 of them because
I need to get another one.
Amazon boxes.
Yeah, they're great. Yeah, exactly. That's why I want to use it for the Amazon box. Just to break them down. But you can get some pretty precise cuts with it, which is nice. And it's kid friendly, so that's cool. Yeah. I forget what it's like. It's some sort of metal, right? Like what is it? Stainless steel blade with Teflon coating.
Yeah, it's the way that the little teeth of the blade are. That
Looks like it's bent. What happened?
Huh?
Yours looks a little bent, doesn't it? Is it? Or is it just the camera?
Might be the field of view.
Okay, I thought it was like bent or something. I was like, wow, you guys really cut through some stuff.
Oh, I mean, the super thick furniture boxes, yeah. I'm
Mm,
surprised it's not more bent if it is.
yeah.
It
All
sounds
right.
really scuffed up from all of the usage.
So, get yourself a canary knife to do the cutting, but then print your own, like,
Yeah,
adapters and stuff. So they got a bunch of stuff. Love cardboard stuff for the kids. So who is this from? This is from, I forgot how to, where's her name? There it is.
Yeah.
ValeriaMomo is their username on Colts 3D. These are, is it paid?
No, it's open price, so you can pay whatever.
Oh, I didn't know that they did that. Wow. So you can kind of like pay if you want to, right?
Mm-hmm. There's a little video for this, super cute. They made this little squirrel box, and they have their squirrel come up to it to grab a nut.
Yeah, that is cool.
A little cute thing.
Yeah, there's some charm to the jagged cuts, I think.
Oh yeah,
shade out there. Construction. The construction is very nice. Just,
yeah, but you can.
I love seeing the
and their cutting attempts right here.
Yeah,
before the PLA blade melted.
Right. I just like the idea of printing your own screws and then using do kit, like tools or something. So I guess lots of tools. All the files are here, right? Somewhere.
Yes, and it's all beautifully laid out, and like all the bamboo plates, so you can.
Oh, that's nice.
Comes out for that.
I love when the designers go that extra step and lay out the plates for their 3MF or whatever.
Yeah,
it's just like renders of the thing. There is some hardware required for the perforation tool, right? Like you were saying.
It is the M25. I did not have any of the 10 millimeter long M25, so I had to use the 10 millimeter M3 screws. Okay. So I just had to use a wrench to force the little M3 nut inside there, but that does work.
Right. Cool. And then also give a shout out to Make Do. They are still selling kits. So want to get kits, and these are great for maker spaces, STEM classroom settings. They have all sorts of different kits. And I
haven't seen these parts here.
Yeah, these proto rings. They like kind of rivets, so like for attaching things together. But their basic kit is only $25. And I like their site just for inspiration of like what you can build. So you're building a kitchenette, a dinosaur, a crown, tiara. It looks like their blade is also metal.
Yeah,
you can't beat metal when you're doing that. But yeah, I remember Gavin helped them build a little choo-choo as well. Here's a little backpack. That is so cute.
Oh, that's so clever.
Yeah, little boat. What else do we have? Doghouse, Pino. This is like major cool, like a dodecahedron or a icosahedron. That's probably the coolest build I've seen with the cardboard.
They might have where it's both the kids are doing homeschooling, and the grants that are given, they might be part of it where you just get it for free.
That'd be cool. The armor, the Minecraft armor.
That's really, really cool.
That's really cool ideas. So yeah, check them out. Even if you just like want some inspiration, it seems that they have some cool. Safe to the touch. Nice. Doesn't cut you. That's cute.
Oh wow, it's cutting like butter.
Yeah, right.
Looks like we're gonna have to go check out if they are covered under the homeschool.
Yeah, right.
Fund.
Maybe. Check them out. And then of course you can print add-ons. If you run out of your make do's, you can just print your own.
Yep.
Cool. And that's on Colts 3D. I got a link for folks in the description and on all the channels here. All right, after that, let's go ahead and hop into Community Makes, starting off with the Severance speaker Severance inspired Bluetooth speaker. This was posted up, I think, a week ago by Mihao on printables.com. I love that they're in an actual like conference room, and the print looks just really nice and clean. Really nice.
Oh, they
added something to it, like a camera. So it's perfect for when you need to talk to the board.
Yeah.
Excellent. I guess, oh, here it is. It says it's printed on a Prusa Mini / Mini Plus. And thanks for posting that up. Folks are still printing this out, which is really cool. Pretty simple build. After that, we have a Kokoshnik. I think that's the Russian doll. The D20 inside a icosahedron. This was a crazy test for PVA support material like 8 years ago or something. So this is posted up by Vic Pylon. It says, worked great. Even with dissolving supports, it is a job to clean up. Yes. That's why you gotta...
We don't need the PVA anymore with how good the tree supports are.
I don't know about that with this particular model.
No.
I don't know how that would work, because you have a lot of they're not intersecting. It's just like crazy.
I was gonna say, if the center D20 is floating, like if you have it in the middle where the tree supports can get to it.
I see. Okay. Yeah. We made the Cricut shaker to really agitate the PVA, because that was the only way to dissolve. Like you have to agitate it, so you use an agitator. Basically, we made our own agitator for this project.
Oh yeah, maybe that's what's missing from.
That's what's missing. Yeah, I remember you had to like poke at it a lot. And PVA is like, it kind of has a shelf life, or it needs to be vacuum sealed or something.
Needs to be dried,
basically glue. Oh yeah, we made different versions of it. One with just one D20, and then one where there's like a D20, a icosahedron, a dodecahedron, like a turducken style D20 thing. Yeah, so they posted it up. Looks good. It's the first make I've seen of this crazy model, but it shows how cool. Oh, look at that little quick time lapse on the Ultimaker 3. Yeah, and then I think we have the Cricut shaker. Oh no, this is a agitator that we designed just for PVA stuff. I want to see if do we have a GIF of it like dissolving? Yeah, here's it.
I thought we did. I remember shooting it.
Yeah, it was really cool. It's probably in the video. Yeah. Anyway.
No, I remember making a GIF of it.
Yeah, I thought so too. Where would it be? Final assembly?
Maybe. Is there usage?
Yeah, I was in the usage page, but.
Oh, maybe it's in the actual.
Yeah, it's in the video.
The icosahedron.
Oh, time lapse.
Yeah.
Yeah. Anyway, if folks are interested in PVA, still pretty neat support material. All right, that's this week's Community Makes. Went a little over time because I like to go down rabbit holes. If you want to pick up anything in the Adafruit shop, please use our coupon code.
I'm laughing at the icon for missing link. It's just a little poop emoji.
Missing link where?
For the box cardboard cutting tools in the Discord.
Oh, I see that now. That's funny. Discord, what happened?
He's so sad.
All right, that's gonna do it. That's gonna do it for us. Yep. Thank you everybody so much for watching tonight. We have more shows. Show and Tell. Liz will be hosting again this week. It starts at 7:30 p.m. Eastern Time. If you'd like to join the Show and Tell, come on by the Adafruit Discord server, and Liz will provide a link you can click on and become a part of the story. Ask an Engineer might happen tonight. I'm not too sure.
I thought they said yeah.
They said yeah?
Yeah,
Okay.
they just need that extra half hour.
Okay. Well, like most things can change. Like
That's true.
on the dime. So tonight, Wednesday, planned 8 p.m. Eastern Time, Ask an Engineer, where you can ask your questions at the end of the show. Tomorrow's JP's workshop. So tune in tomorrow at 4 p.m. Eastern Time to tune in and hang out with Jump Park, building something new. And then Fridays are deep dives with Tim. Tim's hitting up the deep dives every week now. Fridays, 5 p.m. Eastern or 2 p.m. Pacific. Lady Ada's doing her streams on Sundays, so you can tune in whenever those happen on Sundays. And then Mondays are Circuit Python weekly meetings, so you can tune in on the Discord or YouTube or whatever podcast is your favorite on Mondays. JP's product pick of the week every Tuesday at 4 p.m., right? Yeah, 4 p.m. You can get up to 50% off select JP picks. All right, wrapping back around to our show every Wednesday at 11 a.m. Eastern. We're almost at 500.
Wow.
We're I don't know. I was thinking me and Liz go to New York maybe do the show in the Adafruit headquarters or something. I don't know. It's a little bit to get there though. But
oh yeah,
it's like 5 hours.
I was gonna say the
driving.
They haven't set up a studio there for live streaming yet, have they? It's still all out of their apartment.
Yeah, I think so. Yep.
Oh, we forgot. Oh, we'll show it off next week. The kids.
Oh, you're right. Yeah, we're way over time, but for next week we should have a full segment on my kid's first 3D printer and how you can pick up a Bamboo X1 Carbon from Best Buy, which is a accessible, I don't know, appliance store here in the States.
I mean, more accessible than like Micro Center.
Right. Yeah. Weird. Best Buy has beat out Circuit City and CompUSA and what were the other ones? Radio Shack. These like appliance stores.
Didn't Apple used to have printers long time ago?
Yeah, they used to sell 2D. Maybe they still do 2D printers, right?
No, 3D printers. I forget which one it was. Yeah, for a short time. I don't remember what it was. It was still like
Yeah, they're still
not a Bamboo one.
Yeah. All right. Well, that's a cool one for sneak peek for next week. Is an unboxing. Cool. All right, folks, that's gonna do it for us. Thank you so much for watching. Please use your coupon code if you are in the market to buy some stuff. We'll see you next week. But until then, remember to
make
a great day. Bye, folks.